Hey everybody, welcome back. Today it's another project and I'm going to build a power supply just like the one you're looking at right now. I found this on the net about a month ago and I thought that's exactly what I need for doing battery radios. And it looks pretty simple, and I finally managed to get all the parts that I needed: the transformer, the voltage regulator and some Zener diodes. So I'm going to mount it in or on and in this chassis, which you've seen before. The original power supply that I constructed based on Paul Fisher's schematic that he sent to me. Hi Paul! And what I've done, because I quite like this chassis, and I've gutted it and recovered all my electrodes out of it. And yeah, I'm going to whack it all in there. And as you can see, I've already done some preliminary work and I've added in the outputs for the varying voltages from 90 volts down to 22, common there. And that'll be for the filaments, 1.5, on-off switch, my globes, which I hope to power up somehow. And might as well leave the volume pod in there and put a knob on it, at least, I don't know, just for looks I suppose. But let's get rid of that and look at some of the gear that I managed to get. And here's the power transformer, and I got that from Mouser, and all up with postage, $57. And I know it's a PCB mount, but doesn't matter, I'll mount this somehow. And actually it came in really quick. With they delivered using FedEx, and I think I got it about 5 days after I purchased it, so that was pretty good. But what I'd like to do first is attach some power to this, feed it in, give it 110 volts, because that's what I'll be running it on, and see what sort of voltages we're getting out of these other windings. So I'll just hook some temporary power up to it and we'll take some readings. Okay, I've got the temporary power set up and I've got my probes on pins. So yeah, main power's going to pins 1 and 2, and that'll be, like I said, 110 volts I'll input. And I've got my probes on pins 5 and 6, which as you can see, that's the filament voltage, 1.5 volts output. So turn the variac on, already preset it to 110 volts, and we've got 7.7 volts coming out of that, so I'll mark that down. Alright, I'm going to turn it off and take that away. So pins 7 and 8 can be next, and power it up. And we get 7.3 volts off, what did I say? 6 and 5, 6, 7 and 8, pin 7 and 8. So 7.3. And I mean, as you saw on the schematic, 7 and 8s were feeding an extra bias supply. I'm not going to put that in. In fact, 7.3 volts, I think I can bring that down to about 6.3 and power up the lights. So that's alright. Now we'll check the voltage on pins 3 and 4. Alright. And hit the power. Okay, 99 volts. Super. Excellent. Okay, that's all seemed to work well. Alright. What I'm going to do, I'll go through this, reasonably, step by step. And again, this is for you guys that have done this before. Get a bit of a chuckle out of it probably. This is for newbies, who haven't done this before. I've only done it once before, but the schematic looks easy enough. And I'm going to start off by first mounting the power transformer here, and then we'll start from there. Okay, got the mains supply all hooked up, and again, I'm just using a temporary power cord because I'll be powering this off a step-down transformer. and I'll put the proper cord on it later. But yeah, so active through my switch, through a fuse, straight to pin number 1, and neutral, just straight off the power cord over there. So I figured I'd use that little terminal strip. For the next part is the diodes, the rectifier, and so that little bit there. And I've got 1N4007s. I know the schematic says 4006s, but hey, I've got 4007s, and they will do. And I'm going to use that valve socket there, and I'll be able to secure them onto using 4 pins, and do it in the old diamond shape, just like in the schematic. Makes it a lot easier for me. Okay, finally got those little diodes in, and if I look to my schematic, I'm looking at the band, and of course we've got that band there, cathode, there it is, cathode, and then the opposite direction on those two. So our transformer power comes to those 2 points there, and that should then be positive, and that should be negative. So I will get some wiring done and connect them to pins 5 and 6 there and there. Okay, there's the wiring done. So pins 5 and 6 onto the first rectifier. All right, let's see if it works. So what did I say? Positive is there, negative down there, and okay, getting some sort of readings, whatever. All right, I'll turn the variac up slowly. Oh, already at 17 volts. Here it comes, all looking good. Bring it up to 110. 6.52 volts of DC. And yeah, originally, well, I mean, the transformer is pumping out 7.7. Through the rectifier, we get 6.5. Now, I'm wondering if I turn up to 115. Oh, a bit too much there. It goes up marginally, but anyway. Alright, well, that bit's done. Now, I've got to work out how I'm going to the layout for this, and the regulator and a couple of resistors. So probably use terminal strips. So I'm going to look at it and come up with the try and come up with the neatest way, I guess, to do it. Okay, I've come up with my solution anyway. Reasonably neat, reasonably. So all we're doing, positive to the positive output from the rectifier to the positive of the cap, and negative. So there's my 1000 microfarad capacitor. Schematic says 16 volt, but I picked one up and 63 volts. No problem. Just overkill on the voltage. So positives there, negatives there, and I will just whack it in there, such, and then I'll be able to feed from there outwards, be able to feed the rest of the circuit there, the regulator, a couple of resistors, and work out what we do with the diodes. So I think that'll be fairly easy. I'll just run the diodes between there. Probably put another terminal strip in, but I'll get some wiring done and solder that up, and then we'll take it to the next step. Okay, got the cap in and everything buzzes out correctly. Let's connect up the multimeter, and let's just see what sort of DC we're going to be getting out of this. So, bit of power, bring it up to 110. There we go. 10 volts. And I think it's just going to sit there. Yeah. It's going up, up. Not by much. So I have no idea what to expect. Never having done this before. Anyway, alright, 10.10. It's probably just going to go up slowly, but there's no load on it at all. Oh, stabilised. No, not really. Alright, next step. Nowhere to discharge at the moment, so don't touch it. Next step, I'm going to do the regulator. So that'll be mounted directly onto the chassis. It needs a heatsink, and I can't think of a better heatsink than a nice big metal chassis. So I'll find a spot for that and mount it. Okay, we're up to the, well, what I'm calling the voltage regulator. And there it is, LM317T. And I did have a read of it, made in China, of course. And I've checked out the pinouts, and there it is. So exactly like that. Pin 1 is the adjust, pin 2 is in, is voltage out, pin 3 is voltage in. So I'm going to mount the little bugger right there up on the chassis. That'll keep it cool, and then I'll do some wiring and at least hook it up first to the cap, and then look about placing some, at least one terminal strip there to be able to hold on to these resistors. So, alright, and then finally feed it out to these two terminals there. Alright, so there's the regulator secured tightly to the chassis, and I've run a wire from the positive of the cap to pin number 3, which is voltage in. So, there we go. There, yeah, of course. Alright, and I've still got that diode to do, but I'll do that last. So, next thing I'm going to do is run the negative side of the cap, and I'll just run it to the terminal strip there and attach a 56k ohm resistor to pin number 1, and then there'll be a 240 ohm, sorry, that's on, yeah, 56 ohm resistor to pin 1, and off pin 1 we'll then take a 240 ohm resistor over to pin 2. Alright, so here we are, and I've got that 56 ohm resistor in, and that resistor is spot on, and I know that value is adjusting that so we get 1.5 volts out. So I can always play around with that should we need to. Also, as you can see, from the negative it goes to the negative terminal or post, so that wire's in. And what else? Oh yeah, it's gone on to, I've soldered on to pin 1, the adjustment pin. So next, I'm going to take a 240 ohm resistor and run it from that point there on, no, that point there, get it right, yep, that point there to pin number 2, and so that'll go from there to there. So I've made one up, that's exactly, it's 239 point, oh sorry, yeah, 239 point something ohms. I had to make one up, didn't have a 240 ohm resistor. So I'll get that into place. Right, here's our 240 ohm resistor connecting up pins 1 and 2. Yep, just double checking. I've been double checking like you wouldn't believe. So from pin 1 to pin 2, that's done. And I've also, as you can see, from pin 2 goes to the positive terminal. And so I've just run a little red wire there, and I'll solder that up later. So the next step is, oh, that's done. So all I've got to now do is get that diode 4007 between pins 2 and 3, making sure I get the polarity right and not get it around the wrong way. So it's pretty straightforward. It's just allowing voltage to go back into pin 2. Oh, yeah, pin 3, sorry, from pin 2, and not the other way around. Right, so that's all done. It wasn't as hard as I thought. I thought as soon as I applied heat, or the wires and resistors are just going to fall off, but I managed to do it. And yeah, there's continuity amongst from all the connections, so no dry solder joints. Right, one more thing to do on the 1.5 anyway. Where are we? Here we are. So let's run 3 diodes, as it says there, from positive to negative in that configuration. So I'm just going to get 3 diodes, solder them together, and whack them across the terminals. Okay, diodes are in, and I quite like it. Oh well, got to be creative, and don't want to go to too much effort. But hey, we're ready to test. So hopefully I've done this. Actually, before I do, I'm going to take a little bit of time and double check everything, and then once I do, we'll come back and power it up. Okay, it looks all good to me, but still, won't know until we actually power it up. So let's get the multimeter and let's connect it up to our terminals. Let's see if we get 1.5 volts or thereabouts. So, yep, on DC. All right. Power this up slowly. And here we go. Big test. It's bring up to 110 volts. I'm just looking at the variac. And we've got 1.536 volts. Not bad at all. Not bad at all. Cool. Bloody works. Amazing. Huh. Can't believe it. And there we go. And gone down to millivolts. So beautiful. Beautiful. All right. I'm going to have a break. And then I've been at this all day. Geez, just taking my time. Don't want to make any mistakes. I guess it paid off. So far, anyway. That's good. I'm pleased. I'll be back and we'll start on the HT.
That was a beautiful shot, John. No wonder you bow well. You're so fit and healthy. Fred, I owe a lot to Dr. Mackenzie's Mentoids. I used to get such bad backs I could hardly bend. But Mentoids soon success. I feel fine now.
I take Mentoid for backache, rheumatic, or muscular pain. Mentoid. M-E-N-T-H-O-I-D-S.
Okay, with the 1.5 volt all done, let's now start on the B+. So, there's our little circuit there. So it's pretty simple. And yeah, I mean 100 microfarad cap at 200. I've got a 100 microfarad at 450, I think. That'll do. And rectifier there, and then about 4 Zener diodes there, and each to the outlet posts. So far I've done the fiddly work, and there's the diodes ready to be rectified. So I'm now going to run power from the transformer from pins 3 and 4 up to there, and then we'll whack in the capacitor. And I'll just whack it in there. I think pretty good. It won't want to go in, but it will eventually. There we go. So, oh, you can't even see it. Pity. Anyway, so it's just going there. And I'll take it from there. So I'll get that wiring done. I've made a bit of a start on the second part of the circuit, which is the B+. Back to my little hand-drawn diagram. So you can see pins 3 and 4 off the power transformer straight to our diodes, and diodes are in place, pardon me, and there they are. So I've used that valve socket there, you can just see them, and I'll run some wires there. I've got my, where are we here? Oh yeah, my 100 microfarad capacitor. This one's at 400 volts rather than 200 as per the schematic, and I put in a little terminal strip right there, so I'll mount it there and run some wires to it. So alright, so there's the wiring done. Positive feed, negative going to the respective poles of the filter cap. Well, I guess it's filter cap, yeah, and just like the schematic. Where is it? There it is there. So nice and simple. So all we need to do now is, back to this, attach a 2K 2-watt resistor to the positive, and then that'll feed straight off to the 88 volt terminal, and down the bottom I can just run a wire directly from the negative to the negative post. So I put in another terminal strip up there. I've got heaps of them. I keep them from all the chassis I strip. And so there's my 2-watt resistor, so I'll just put it there and secure it in place so it's not flopping around. And yeah, I bet you that falls. Yep, there you go. And yeah, take a wire from there again to the post. So I'll solder this up and secure it all, and run those wires to the 2 posts, and then we've only got the Zener diodes to put in place. Alright, so here's the last leg of this build, and I've run the negative and positive wires to the posts, and the connectors on the posts, I just use these automotive connectors. I just twisted off the insulation and bolted them on, and hey, these are great. And our first Zener diode is in, and next one, and I've just bent them and cut them to size, and they should just fit in there as second one. And I'll do the other two, solder them up, and then we can give this thing a test and see if B plus works. Okay, soldering is all done, as you can see, and let's give it a test. So I've attached a probe. Let's get that on that post. Gotcha. Alright, so we'll go from the bottom up, and as you can see, first one should be 22 volts. So let's check that out. And I've got the Variac set up at 110 volts, so I'm just going to switch on. And we've got 21.99, 22 volts. It's going to keep on going up. Looks like it's stabilising there. That's pretty good. What's our next voltage range? 44 volts. 44.6, 4.5, and nice and stable. Great. Works. Next one, 66, actually it's 67, that's not a problem. And a final one, B plus, 90 volts, where are you? Stay on there. 89, or yeah, 89 volts, and they specify, well the schematic specifies 88. Whoop. So just monitor that for a few seconds, see how stable it is. And there's no load on it, of course, but that's pretty good. That's pretty good. Wow, it works. Alright, I'm just going to tidy up a few loose ends on this and get a proper power cord on there. And yeah, picks up this, get the lights to work. And I'll come back and we'll finish up the video. Well, there it is, and it's all completed. And I put on an American style plug. And just to make sure that I don't plug this into a 240 volt outlet. And that just goes into my step down transformer. And might as well plug it in. Turn it on, and wacko! It done. So, as I said, this will come in extremely handy. There's no doubt about that. I think you can see that. And just to make sure all the voltages are there. So, yeah, 1.5. Get in there. 22. In. 44. 66. 88, close enough to 90. So, you probably didn't see the other ones, but yeah, I read them out, don't worry. Anyway, that's it, guys, and I think this cost me, let me see, a transformer I got from Mouser, and that was $28, but with postage. FedEx delivery too, got that in within 4 days. It was about $58, and the only other things I had to buy were the posts there, and they were $2 something each, unfortunately, from J-Car, but, you know, when you need them, you need them. And the rest I had just lying around, you know, certainly I paid for them, so I reckon, I don't know, $75 to put this together. Not bad at all. So, anyway, that's it, and I will put a link down below for the schematic. Came off a radio thread, as I recall. Anyway, and you can just have a look on that, and it's there should you not be able to find it anywhere else. So thanks again for watching, guys, and I'll catch you all again very, very soon. Take care. Bye. Have fun.